Welcome to the first episode of the Reasonable Theory podcast. My name is Jeremy Kurtz, and I'm here at the Men with Toupees test kitchen. And our goal of this podcast is to look at different oddities that occur on our planet, outside of our planet, in our planet. And we're going to do that without using any type of extraordinary mathematics or physics. We want to take a look at different things and utilize the logic we have, as opposed to applying ideas that are metaphysical in nature. We're not going to try to prove the existence of ghosts by using some weird little handheld device that makes you cry out in fear because there's a ghost in the room. What we're going to do is we're going to use basic science and basic logic. What we're going to do today, though, is we're going to talk about the formation of the solar system. And seems like a lofty goal for the first episode. I mean, we're going to talk about how the solar system was formed. So when we come back from this commercial, we'll get started. My name is Jeremy Kurtz, and I'm really glad to have you here today. And by the way, thanks Isabella for the cup. I love it.
Put your hand around a country club can. It's a great bottle of liquor you got. Country club is a lot to drink. Without drinking a lot, start something good. Put your hand around a country club can. It's a great bottle of liquor you got. Now it's understood. Country club is a lot to drink. Without drinking a lot.
Welcome back, and thanks for the ad from Country Club Malt Liquor. It is definitely the malt liquor of choice for the men with toupees. So here we go. We're going to tackle the formation of the solar system, which once again is quite lofty for the first episode of Reasonable Theory, but we might as well get it out of the way. And it's a little funny talking about this because I'm going to talk about a theory that I've never read before, and I worked on myself, but I cannot believe that someone else didn't think about this. And I would really like it if in the comments, if somebody knows, please put it there. I'd like to give it proper credit, and I would like to read more information about it. But it certainly makes a boatload of sense as to how our planets, our sun, everything came together and the formation in which it did, and things that can happen as a result of that method of development. So let's get started. We have a sun. The sun is 4.6 billion years old, and every year the sun shrinks 76 centimeters. Now, those are readily available facts, and there's nothing that exciting about it other than the sun shrinks 76 centimeters per year. But if we take it and look it over the course of the entire lifespan of the sun so far, you'll see that the sun has shrank 340 million kilometers since its inception 4.6 billion years ago. Now, let me say that again. It has shrank 340 million kilometers since it began 4.6 billion years ago. So what are the assumptions? Well, the first big assumption is that I'm saying that the sun is 4.6 billion years old. I don't know that for a fact. I read it in a science book. Somebody must know, or they read it in a different science book. But if we take that as one of our givens, and we take as another given that the sun shrinks 76 centimeters per year, and we make the multiplication, and we're going to make the multiplication, but if it shrinks 76 centimeters per year now, there is no reason to think that it hasn't shrunk 76 centimeters per year since it became our sun 4.6 billion years ago. So if we do just a little bit of multiplication, we will find out that 340 million kilometers have left the sun since it first became the sun. Well, who cares, right? So what? Well, this is what led to the theory. The sun, as it shrinks, and we also have to consider that the sun is gases and plasma. Plasma, the fourth type of matter, and we also know that the sun ejects plasma, and we also know that that plasma that gets ejected sometimes comes in, sometimes goes out. So let's think about this for a minute. Let's say we have a sun that is 4.6 billion years old, and then all of a sudden it ejects exactly the right amount of plasma there where the gravitational pull of that planet and of the sun are such that it rotates in formation or orbits the sun in a fashion where it's in equilibrium with gravity. And let's say it happens again. Only this time, the gravity of the second ejection of plasma now plays against the first ejection of plasma and the sun, and it magically sits in between the two, also creates an orbit because of different mass or density at a certain temperature. Its revolution around the planet is a bit different than the first one. We can also presume that ejected plasma might also attach itself to one of those orbiting entities, and it changes the gravitational tension in between everything that is set on this balance with the sun. So what does this tell us? Why does this matter? Well, let's take a look at an interesting piece of math. Right now, the Earth is 4.6 billion years old. Now, we got to have some give and take. And I'm going to give up that 4.6 is a number that I looked up, because that's the purpose of this. I'm not going to do a bunch of calculus. But we're going to say 4.6 billion. And in the course of 4.6 billion years, the ejection, the moving back of plasma, the developing relationship between each gravitational pull that has remained in orbit and the sun has caused this perfectly balanced solar system. Now, my guess is that you're going to say, well, you're full of crap, but that's fine. B, you're going to say, well, if that's true, then how do we prove it? Well, let's take a look at, just for a moment, the idea that Pluto used to be a planet, but now it's not a planet. And as it was moving its way out to where it became the ninth planet in our galaxy, we study Pluto. And there's a very interesting thing that you're going to find out, and I hope you look it up. And if you prove me wrong, that'd be great. Let me know in the comments, and I will fix it. My goal is to get to some, a reasonable theory on how things work. But if you take a look, you'll realize that Pluto is 4.4 billion years old. Let that sink in for a moment. If the theory is true, there's a time at which Pluto actually occupied the location that Mercury occupies right now. But as ejection, retraction, all these things take place, the alignment of the planets mathematically move in and out of sync. And there could have been some extra ones that slammed together. That would make sense why we have an asteroid belt. But what we're left with is 9 planets that seem to orbit the sun and rarely shift from that orbit. So, how did we become so lucky? Because the goal is not to just consider how the solar system was created, but I contend that because of this theory that life can exist on other planets, and actually has existed on other planets. So, we take a look right now at Mars, for example, which is the closest planet to us. So it's the 4th planet. So it's closest to our planet, going the bad way. We're going to call towards Pluto bad, towards the sun bad, and Earth we're going to call the sweet spot. If the theory is correct, there was a time at which Mars sat in the sweet spot, where it was far enough away, it was close enough, the rotation was correct, there developed water. It was indeed Earth-like in its formation. Well, it's a lot like science fiction movies. We say, well, there's all kinds of aliens on Mars. But look at some of the rocks that came off of Mars. There is definitely some speculation worth thinking about that there is water under the surface of Mars, and rocks have come back to show that there could have been living things in these rocks in the form of fossils. So feel free to look that up as well. But very small worm-like creatures that created or turned into fossils and embedded themselves into the rock and came back to the Earth for us to study them. Now, I'm not going to rest my hat on this theory. What we're going to do is we're going to say, okay, that's how I think the solar system was put together. And this is why I think life exists on other planets. By the way, if my theory is correct and we are in the sweet spot, pretty soon we're going to earn, pretty soon, I don't know what pretty soon is, sometime, the Earth is going to move from the sweet spot. We know that Pluto has moved enough that we don't even care it's a planet. That's kind of like growing up with 50 states and all of a sudden now we only have 49. No, there's still 50. Just, there's 50. Anyway, I grew up my whole life thinking there was 9 planets, and then some guy comes out and says, hey, there's only 8. Well, that's upsetting to me. But for some reason, that 9th planet became a not planet. And if that's the case, the possibility of that occurring again is very likely. So my theory culminates in the idea that the planets, as they move and relate gravitationally to each other, that the ones on the outer reaches of the solar system will continue to go to the outer reaches of the solar system, and all of a sudden they will become not a planet. So it is likely in the theory that I spoke about that Venus is the next Earth. It's moving into the sweet spot. We are moving from the sweet spot. Now, that's not an alarmist. I'm just saying that could be a logical conclusion to a theory I never read about that probably belongs to someone else. But it's possible. And there could be a new Mercury. So what does all that mean about life? Well, if we look inside the Milky Way galaxy, there is exactly, not really exactly, there is 200 billion stars in the Milky Way galaxy. Now, that's 200 billion. That's like a lot. Like this much. What we need to consider is how many of those could possibly have planets surrounding them. And the thought is we have no freaking idea. But let's do some really simple math. So, currently there's 200 billion suns in the Milky Way galaxy. Let's say that 1/10 of 1% of those suns have a minimum of 3 planets orbiting them. So, 200 billion, 1/10 of 1%. And we're not even going to say they have to have 9 planets, because I have an idea about the whole 9 planet thing that we'll talk about. But let's say there's 3. 1/10 of 1% have 3 planets. That's 600 million planets that could exist within the Milky Way. Now, I didn't go less than 3, so I'm not even count the ones that could have 2 or 1, and I'm certainly not counting the ones that have 4 or more. We don't know. We know what telescopes see, we know what they tell us, but we're not privy to information about 200 billion stars. It's such a vast number that it's even hard to think of 1/10 of 1%. So, let's say 1/10, 1% has 3 planets, and we can even say 3 planets or more. We can just say 3 or less. But I just picked 3. And we can say that that is 600 million planets in our galaxy, in just the Milky Way galaxy. Now, what do we know for sure? We know that our solar system has 9 planets. If the theory of how the solar system was created is correct, and a sun has 3 planets, it's a pretty easy assumption to say that that is a young solar system. We can say ours is an old solar system. You know, 4.6 billion years is a long time ago. I'm sure there are suns that have not been around for 4.6 billion years. There's suns that have been around for less, there's suns that have been around for more. If at 4.6 billion years we were to develop the world as we know it, the likelihood of a solar system existing with life that is older than ours is about 1 in 9, 10. We'll say 1 in 9 because we have 9 planets. So what I'm saying is we have 9 planets because our solar system is older. And at one time Mars had life, and at one time Venus will have life. Mercury will become the second planet, and there will be a new planet formation closer to the sun. And I believe this is how solar systems are created within a galaxy. So when we consider that 1 in 9 theory, it is like going to a horse race, betting $100 and only winning $12. That's the odds that life doesn't exist. Well, thanks. This is the end of the first episode of Reasonable Theory. In part 2, we're going to explore actually aliens a little bit more. We're going to try to talk about where they may come from, where they go, and we'll also talk about time, because I don't really think time is on our side. So have a great day and see you next time. And don't forget to hit the like and subscribe button. I'd really appreciate it. Thank you.